Imagine for a moment that you are walking into a hospital nursery. You walk past the rows of clear plastic incubators, expecting to see newborns, fragile, tiny things, barely opening their eyes, perhaps crying softly. But in the very last crib, you don't find a baby. You find a fully grown man. He is 6 feet tall, weighs 200 pounds, and has a full gray beard. He looks at you, checks his watch, and asks you for a cup of coffee. Your brain would break. It creates a logical impossibility that you cannot reconcile. How can something be so old when the timeline of its life says it must be young? It feels like a glitch in reality. This visceral sense of wrongness is not a hypothetical scenario. This is exactly what happened to the entire field of astronomy in July 2022. For decades, we thought we had it all figured out. We clung to a story about how our universe began, a narrative that felt as solid as bedrock. It was a neat, tidy framework called the Lambda-CDM model. Think of this as the standard recipe for the cosmos. Take a little bit of normal matter, mix in a lot of invisible dark matter, and add a huge amount of dark energy to push it all apart. This model gave us a timeline we felt safe in. It told us that the universe started with a Big Bang, followed by a long, opaque era known as the Dark Ages. Then, slowly, painfully, gravity began to pull small clumps of cold gas together. Over billions of years, these messy blobs merged to form stars, and those stars merged to form galaxies. It was a slow, hierarchical evolution from chaos to structure. We wrote this history down in our textbooks. We taught it in our universities. We built our careers on it. We constructed a paper universe, a perfect history book that described a timeline we felt we understood completely. But that certainty was an illusion. It was a temporary scaffold we built to hold our understanding together, and the James Webb Space Telescope just kicked that scaffold over. The astronomical community waited a generation for this telescope. After nearly 15 years of delays and ballooning budgets, we finally launched humanity's most powerful eye into the dark. When JWST finally opened its infrared shutters, we expected to see the faint fuzzies, the baby pictures of the universe that the Hubble telescope had hinted at. We expected to see those messy, chaotic, dim blobs predicted by our models. We were ready to confirm what we already knew. But the universe had other plans. Instead of babies, we found adults. Deep in the void, less than 500 million years after the Big Bang, the telescope found galaxies that were massive, bright, and structured. These were not the dim sparks we predicted. These were universe breakers. Objects like the record-holding JWST 14.0 or the massive candidates identified by Evo Labe appeared to be as heavy as our own Milky Way. Yet they existed when the universe was only 3% of its current age. According to every law of physics we know, there simply wasn't enough time for gravity to pool this much gas and convert it into stars. It is as if the universe skipped its own childhood entirely. The standard model didn't just get a bruise. It was ripped to shreds and thrown in the trash. We are now standing in the rubble of that theory, realizing that our map of the cosmos was wrong. The discovery has triggered a crisis in cosmology, and honestly, it is a wonderful thing. But I need you to listen closely. The headlines you have seen, claiming the Big Bang is dead or that physics is broken, are often loud, messy, and misleading. The truth is far more nuanced and far more terrifying. This video is not a soundbite. It is a 25-minute investigation into the biggest mystery of our time. We are going to look at the evidence, the impossible numbers, and the suspects. We are going to journey from the safety of the paper universe into the dark, confusing reality of the actual one. So, turn off your notifications, settle in, and commit to the journey. Let's look at the galaxies that shouldn't exist. To understand the sheer magnitude of this crisis, you have to understand the specific timeline we were working with. Before July 2022, we had a very comfortable, very polite agreement with the universe. Think of this as the standard recipe for the cosmos. You take a little bit of normal matter, mix it with a lot of dark matter, and let gravity bake it over billions of years. According to this recipe, the early universe should have been a chaotic, messy place. It was the Dark Ages, a time when the first stars were just barely flickering on, slowly pulling themselves together. We expected the James Webb Space Telescope to act like a time machine, peering back into this era to find the cosmic equivalent of toddlers. We expected to see faint fuzzies, small, ragged blobs of gas beginning to merge. Small things that would eventually, over billions of years, grow into the majestic spirals and ellipticals we see today. That was the story. That was the history written in the standard model. Then, the first images downloaded. You probably remember the first deep field released by President Biden. But to the astronomers sitting in front of their screens, watching the data stream in, it was a crime scene. In the background of those images, hiding behind the massive galaxy clusters, were tiny red dots. To you and me, they looked insignificant. But when astronomers analyzed the light from those dots, breaking it down into a spectrum to measure their distance and mass, the blood drained from their faces. They weren't faint fuzzies. They were monsters. This brings us to the core metaphor of this entire crisis. I want you to imagine walking into a hospital nursery. You are expecting to see newborn babies sleeping. That is the early universe we expected. Now, imagine you walk to the first crib, pull back the blanket, and instead of a newborn, you find a fully grown man with a thick beard, weighing 200 pounds, squeezed into the crib, staring back at you. That is the visceral shock of what JWST found. These red dots, known now as the Lambda objects or the universe breakers, were located deep in the universe's infancy, between 300 and 500 million years after the Big Bang. Yet, they were massive. Some of them appeared to have stellar masses comparable to our own Milky Way, roughly 10 to 100 billion times the mass of the Sun. This is where the logic breaks. Our own galaxy took over 13 billion years to grow to its current size, eating its neighbors and slowly accumulating gas. These galaxies had done the same amount of work in less than 500 million years. They had lived a lifetime in a heartbeat. They were mature, structured, and bright when they should have been nothing more than dust and gas. I want to pause here. We are talking about rewriting the history of everything. I'm curious. When you hear that the standard model might be broken, what is your immediate reaction? Does it make you feel anxious that we know less than we thought? Or does it make you feel excited that there is still magic left to discover? Let me know in the comments. Do we want a tidy universe or a mysterious one? Okay, let's get back to the panic. And I do mean panic. When these results first hit the internal Slack channels of the astronomy community, the reaction wasn't immediate acceptance. It was denial. You had brilliant scientists like Erica Nelson looking at the data and saying, "It's bananas." You just don't expect the early universe to be able to organize itself that quickly. The numbers were simply offensive to the laws of physics as we understood them. To build these galaxies so quickly, the universe would have had to convert almost 100% of all available gas into stars instantly. In the modern universe, galaxies are inefficient. They are messy eaters, converting only about 10 to 20% of their gas into stars. But for the universe breakers to exist, they would have to be perfect engines of creation, wasting nothing, operating at an efficiency that physically shouldn't be possible without blowing themselves apart. It wasn't just one freak accident either. It was a population, 6 distinct candidates, all impossibly heavy, all impossibly early. It was as if we looked at a photo of a kindergarten class and found half the students were wearing business suits and holding PhDs. The timeline didn't fit the picture. The standard recipe said there wasn't enough time for gravity to pool this much material together. Yet, there they were, bright and red, mocking our models from the edge of time. The baby had a full beard, and he was staring right at us. To understand why this beard on the baby is so terrifying, we have to look away from the pretty pictures and look at the ugly math. In astrophysics, there is a concept known as Borean conversion efficiency. It strictly describes how good a galaxy is at turning raw gas into shining star. You might assume that if gravity pulls a massive cloud of hydrogen together, it naturally collapses into a star cluster. But the universe is messy. Imagine a toddler trying to eat a bowl of spaghetti. Most of it ends up on the floor. That is a galaxy. As soon as the first stars ignite, they declare war on the cloud that made them. They blast out radiation and explode as supernovae, driving powerful winds that push the remaining gas away. It is a cosmic tug-of-war between gravity pulling in and stellar feedback pushing out. In the modern universe, the feedback usually wins. Galaxies are incredibly inefficient engines, typically converting only about 10 to 20% of their available gas into stars before the rest is blown away. This 20% limit is not just a suggestion. It is a boundary set by the physics of thermonuclear explosions. This brings us to the crisis. When astronomers analyzed the light from these universe breakers, they calculated their mass and compared it to the age of the universe at that redshift. Using the Lambda-CDM model, we know exactly how many dark matter halos should have formed by that time. We also know the universal recipe. For every kilogram of dark matter, the universe provides a specific, small allowance of normal gas. This gives us a strict upper limit on the fuel available to build these galaxies. Even if these ancient galaxies were perfect machines, utilizing 100% of their gas, an efficiency that is physically impossible, they would still barely be massive enough to match the JWST observations. But galaxies are not perfect machines. To explain the mass we are seeing, they would need to be converting nearly every atom of gas into a star instantly without any waste, inside dark matter halos that are themselves growing faster than our simulations say is possible. This is where theoretical astrophysicist Mike Boylan-Culkin enters the story. He realized these 6 candidates were not just outliers, they were violations. He published a stress test for the standard model, calculating the absolute maximum mass a galaxy could theoretically achieve by this point in time, assuming the most optimistic conditions possible. He drew a line on a graph known as the Boylan-Culkin limit. The galaxies JWST found were sitting right on top of this line, and some were daring to step over it. It was a mathematical impossibility. Think of it this way. Imagine you are standing next to an Olympic-sized swimming pool. You are handed a garden hose and told to fill the entire pool in exactly 5 seconds. You know the flow rate of the water and the volume of the pool. It does not matter how skilled you are. The physics of water pressure and pipe diameter simply do not allow that volume of water to move that quickly. Gravity is the water pressure. The dark matter halo is the pipe. The laws of physics dictate a maximum flow rate for how fast gas can fall into a galaxy. Yet, when JWST pointed its mirrors at the dawn of time, it found the pool was already full. The water was there, the hose was still running, and the cosmic stopwatch read 5 seconds. It is physically impossible, given the flow rate of gravity as we currently understand it. I want to pause here, because this is where the story stops being about distant rocks and starts being about us. We often view science as a monolithic book of answers, but right now, you are watching the pages being torn out. When you hear that the fundamental laws of the universe might be wrong, what is your visceral reaction? Does it make the cosmos feel more magical or just chaotic? Are you rooting for the standard model to survive, or are you secretly hoping for it to break? Pause the video for a second and let me know in the comments. I'm genuinely curious if this crisis feels like a failure or a victory to you. Now, back to the precipice. The existence of these galaxies forces us into a corner. If the data is correct, it means one of two things. First, we might be fundamentally wrong about how stars form. Perhaps in the early universe, the laws of thermodynamics were different, allowing gravity to win the tug-of-war completely. This would be a revolution in astrophysics, but the second option is even more radical. It suggests that the standard recipe of the universe, the Lambda-CDM model itself, is flawed. It implies the timeline we have drawn for the cosmos is wrong. Maybe there was more dark matter in the beginning, or dark energy acted differently. This isn't just a surprise. It is a crack in the foundation. The universe breakers are not just heavy galaxies. They are evidence that the universe was efficient at creating order long before we thought order was possible. We expected a dark, chaotic nursery. Instead, we found a fully built city. And currently, we have absolutely no idea how it was built so fast. Naturally, the first response to finding a skyscraper in the Stone Age isn't to rewrite history. It is to check your eyes. When these images first flooded the secure Slack channels of the astronomy community, the mood wasn't immediate acceptance. It was deep, professional denial. You had PhDs, people who have dedicated their lives to the Lambda-CDM model, typing, "This cannot be real. The calibration is off." Because if these dots were real, everything they had taught in lecture halls for 20 years was suddenly on shaky ground. It was a moment of pure scientific vertigo. So, the scientific detective work began. They needed to interrogate the suspects. The first suspect is always the same in astrophysics: dust. Cosmic dust is a trickster. It absorbs blue light and lets red light pass, called reddening. To Webb, a young dusty galaxy nearby can look suspiciously like an ancient, pristine galaxy at the edge of time. We saw this happen. Early on, an object named Sears 93310 was hailed as a universe breaker. Photometry, estimating distance based on color, suggested it was at redshift 16, mere moments after the Big Bang. But when the team looked closer, the alibi crumbled. It wasn't ancient, it was a dusty imposter at redshift 5. The community exhaled. "See," the skeptics said. "It's just dust. The model is safe." But then a second suspect emerged. Astronomers began noticing a specific type of object they called little red dots. These weren't fuzzy galaxies. They were compact, piercingly bright points. The theory shifted. Maybe these weren't massive galaxies full of stars. Maybe they were supermassive black holes, quasars, gorging on gas. A feeding black hole is an engine of pure radiance. If a black hole is that bright, it could fool us into thinking we are looking at a galaxy with 100 billion stars, when really we are just looking at one angry monster. This hypothesis, the AGN solution, became the lifeboat for the standard model. If they are black holes, we don't need to rewrite star formation. We just have a different mystery. How did black holes get that big? that fast. To solve this, we had to move beyond pictures. We needed a fingerprint. In high redshift astronomy, taking a picture is just a guess. You need DNA. You need spectroscopy. By using the NIR-SPEC instrument, Webb can take that tiny smear of red light and stretch it into a spectrum. We are looking for a specific signature known as the Lyman break. Neutral hydrogen in the early universe acts like a fog, absorbing all light at specific ultraviolet wavelengths. This creates a cliff in the spectrum, a sharp drop-off where the light simply vanishes. The location of that cliff is non-negotiable. It doesn't lie. If the cliff is at a certain wavelength, the object is at that distance. It is the mathematical proof of exactly when the light left the object. This brings us to the edge of the cliff. We have the suspects, and we have the tool to catch them. But before we reveal the results, I want you to weigh in. We are standing at a fork in the road of human knowledge. On one side, the safety of the standard model, the idea that these are just black holes or dust. On the other, new physics, the terrifying excitement that we are wrong about the universe. Which way do you lean? Are you a skeptic or a believer in the broken universe? Pause the video right now, go down to the comments, and cast your vote. Skeptic or believer? I want to know where you stand before the evidence drops. The astronomers loaded the targets. They pointed the spectrograph. They prayed for dust. They prayed for imposters. And for some, they got them. Several candidates turned out to be lower redshift interlopers. But then, the data came back for the others. The spectrum for a galaxy called JWST Z14-0 appeared on the screens. It was a heart-stopper. The Lyman break was there, sharp and undeniable, locking the galaxy in at redshift 1432. That is less than 300 million years after the Big Bang. This wasn't a dusty neighbor. It was a ghost from the dawn of time. But the spectrum revealed something else, something that killed the black hole theory. The light wasn't coming from a single compact point. It was coming from a sprawling structure. The galaxy is over 1,600 light-years across. A black hole cannot fake being 1,600 light-years wide. This means JWST Z14-0 is exactly what we feared, a massive, luminous, fully formed galaxy. This is the moment the detective realizes the imposter theory won't save us. We cleared the room of the dusty decoys. We identified the black hole masqueraders. And yet, the biggest, scariest suspect is still sitting there, staring back unblinkingly. JWST Z14-0 proves that the universe could organize itself with terrifying speed. It didn't need billions of years to build the first great cities of stars. It did it in a heartbeat. The fingerprints have confirmed the crime. The standard model didn't just get a speeding ticket. It crashed into a wall. The suspects are real. The crisis is real. And now, we have to figure out how a cosmos so young could look so hauntingly old, and what that means for our place within it. This brings us to the edge of a sensation astronomers are feeling. It is a specific kind of intellectual dizziness, a cosmic vertigo. Because when you look at JWST Z14-0, you aren't just looking at a galaxy. You're looking at a violation of the rules we thought governed reality. To understand this disorientation, you have to understand how inefficient the universe usually is. Galaxy formation is usually a messy, wasteful process. Forming stars is like a toddler eating a birthday cake. It makes a mess. As soon as stars ignite, they explode as supernovae, blowing away the rest of the fuel. A typical galaxy converts only about 10 to 20% of its available gas into stars. The rest is wasted blown back out into the void. This inefficiency is a cornerstone of our standard model. It's the absolute speed limit of the cosmos. It dictates how fast things can grow. But these new galaxies, they are ignoring the speed limit entirely. Astrophysicist Mike Boylan-Culkin ran the numbers in what he called a stress test for cosmology. He found that to be this massive, this early, they cannot be messy toddlers. They would have to be hyper-efficient machines. They would need to convert nearly 100% of their available gas into stars instantly without wasting a single atom. This defies the physics of gas collapse. This level of productivity is physically impossible under our current understanding of star formation. It is like walking onto a construction site where the foundation was poured an hour ago and finding a fully finished 100-story skyscraper, complete with furniture and tenants. It implies that the early universe was not a chaotic, fumbling dark age. It was a period of frantic, terrifyingly efficient creation that we never predicted. This is where the vertigo sets in. For decades, we told ourselves a specific story. We called it Lambda-CDM. It was a neat, tidy narrative where small clumps of dark matter slowly merged to build the galaxies we see. We became arrogant. We thought we were reading the final chapter of a solved mystery. We thought we were just filling in the minor details, dotting the I's. We believed the universe was understood. James Webb has revealed that we are not reading the last chapter. We are actually barely on page 1 of an entirely new genre. And this is the most beautiful part of the crisis. If the standard model is broken, it doesn't mean science has failed. It means the universe is far more interesting than our equations allowed it to be. A solved universe is a dead universe, a boring universe, but a broken universe, however. That is a place of infinite mystery and possibility. It means the adventure is just beginning. The fact that these galaxies are adults when they should be infants forces us to confront a profound possibility. If the cosmos can organize itself into massive, structured galaxies just a few 100 million years after the Big Bang, what else did it organize? We used to think the early universe was too hostile, too hot, and too chaotic for complex chemistry or life to take hold until billions of years later. But if the structures for life, the galaxies, the stars, the heavy elements like carbon, were in place almost immediately, then the window for life in the universe might be billions of years wider than we dared to dream. We are looking at a universe that is desperate to create. It is not a slow, cold void, allowing structure to emerge over eons. It appears to be a fertile, aggressive engine of creation that raced to build the lights of the cosmos the moment it was born. We are not latecomers to a slow party. We are waking up to the realization that the party started long before we thought the invitations were even sent. So, here is the question that keeps me up at night, and I want you to truly sit with it. If the universe is this efficient at building galaxies, if it rushes toward complexity with such frantic speed, does that mean that life is not a lucky accident, but a cosmic imperative? Is the universe actually designed to wake up? I want to hear your theory in the comments below. Do you think this breaks the Big Bang, or just our timeline of it? And to join us as we rewrite the entire history of everything, make sure you are subscribed with the notification bell on. The story of the universe is changing, and we are just getting started.